Hey everyone, welcome back to the channel. Like you see the number of changes, and today in this next part of building the project and completing the DevOps, I want to get into the GitOps. So you see there is a GitOps directory here. There is a .github directory that we have already had, but a new change in the workflow with new files, a new script, and a new workflow file. So we're going to look at them very quickly. But before that, let me go through what we've built and talk about a few terminologies before we continue. So what do we have yet? Okay. What we have right now is very basic. Okay. We have GitHub Actions. Okay. So if I can type this correctly, we have GitHub Actions, and then the actions or the workflow and the steps in the workflow execute a particular task. Actually, let me have this on another line. Okay, we paste it down here. Okay, this is good enough. So we have GitHub Actions, which helps us to run Helm upgrade. If you don't know what Helm is, please check the past 6 videos in the playlist that come before this. You'll understand. And then Helm helps us to set up everything, okay? Deploy our application to EKS. Now there's going to be a change, okay, in the new files I've showed you. And this change is going to be that this time we're going to have a different approach, okay, a different flow. And the dev, or we the developers, will push, okay, as usual, to GitHub. When we push the backend code, then GitHub Actions will do its thing. Okay, we have GitHub Actions doing its thing. After GitHub Actions does its thing, actually, what do I mean by doing its thing? In this case, I mean that it will test, okay, run the tests and build the image. Okay, run the test and build the image. I wanted this to be in a different color. I don't know why it kept the same color. I think I didn't change it. Yeah, that's my bad. All right, we have GitHub Actions, okay? Building the image. So it first runs the tests for us. Then after that, we have the image being built. After the image is built, the next step is for GitHub Actions to push the image to ECR. So GitHub Actions pushes image to ECR. Maybe white is just good enough for this, okay? Just avoid having many colors. I hope that does not hurt your eyes. Sorry if it does. So GitHub Actions pushes the image to ECR. Again, if you don't know what this is, please check the previous videos in the playlist. You'll understand what is going on. After that, the same GitHub Actions, okay, is going to push, okay, not to push, but record, okay, and you're going to see how that is going to happen. It's going to record the image tag in Git, okay, as simple as that. It's going to record the image tag in Git. After that image tag has been recorded in Git, then we shall have our tool that we are introducing called Argo CD that will detect the change, okay, the Git change. And once it detects that change, it will reconcile it, okay, to in EKS, okay, to make sure that what is in EKS matches what is in Git. So I'll just type it out. I'll say Argo CD, sorry, Argo, what's happening? What lowercase? Argo CD then reconciles what is in EKS to match what is in Git. As simple as that. So this is going to be the new setup. Okay. So yeah, let's now probably get into it. Maybe before we go to that, I can talk about the infrastructure split for now to make sure that everything is very, very clear. So place this down here, okay, and talk about the responsibility split. Okay, most of the things actually are doing the very same things with just a few tweaks. Okay, so we still have Terraform. Maybe let me first type them out. We have Terraform, we have GitHub Actions, we have Helm, we have now Argo CD being the new guy. We have Doppler, sorry, Doppler like that, okay? And we have Kubernetes. Now, Terraform, like you know, is responsible for the AWS infrastructure, EKS, IAM, ECR, Redis, and SEM. Then we have the GitHub Actions being responsible for testing, okay, running the tests, building the image, pushing to ECR, and image promotion in Git. And we shall see how this happens. Then we have Helm. Helm is responsible for the packages, okay, and rendering the Kubernetes resources for us. Then we have the new guy called Argo CD, who is responsible for continuously reconciling Git with Kubernetes. Then we have Doppler, which simply supplies runtime configuration and secrets. And finally, we have the K8 guy who runs the API, runs the worker, runs the migration job, runs the service, and ingress for us. So Argo CD does not replace Kubernetes, okay? It does not replace Helm, it does not replace Terraform, it does not replace Doppler, it does not replace GitHub Actions. It simply becomes the controller responsible for the desired state of Kubernetes applications, okay? As simple as that. Then I want to go to the files, okay, and then explain to the changes. But maybe before that, there are other terminologies I need to talk about, okay? So that when I'm talking about the files and what has changed right inside here, okay? Things make sense to you, okay? So let's maybe first create another. I'll copy this again, replicate it, drag it down here, and say, what can I call it? What have we said actually? Terminologies of vocabulary. Okay. And yeah, and just again duplicate this and yeah, got one by one. So like you see, we have a directory here called GitOps. Okay. So if you don't know GitOps, this will be just like a brief introduction. So let me try to list out everything I think I should talk about, then maybe explain one by one. So we have GitOps, the term called desired state that I'll talk about. We have live state. Then I've already touched on reconciliation. What's the spelling? Like that, I think. Then we have what we call a drift. Or maybe let me go through each, okay, as I continue. So let me start from the top. What is GitOps? Sorry, I meant to change the color, but let me pick something different for the pencil. Okay, GitOps. So GitOps simply means that Git will contain the reviewed desired state of a system. The controllers will read Git and make the live environment match it. Okay, so we shall have Git storing our image tag, and then GitOps controller will check EKS to make sure that it has that current image. If it doesn't, then there will be reconciliation. So GitOps simply means that Git contains our reviewed desired state of our system. And then the GitOps controller reads Git and makes sure that our live environment in EKS matches it. And I've touched on desired state. Maybe I should have explained it first, because I mentioned desired state while talking about GitOps. But desired state simply means configuration stored in Git. Okay. An example which applies to our case will be the backend image tag. Okay. That is the desired state. Another one can be the replica count. It could be the service and ingress. Okay. We can say in Git that we want this image tag, we want this replica count, we want this service, we want this kind of ingress configuration. So it is simply the configuration stored in Git which we want to be in the EKS. Then we have live state. You might have guessed what this means. So live state simply means the state which is currently running in Kubernetes. And the GitOps controller will make sure that what we desire, what is stored in Git, matches what is in the live state. So if someone manually changes the live state, the controller will make sure that the desired state is implemented in the live application so that we have our live state being the same as the desired state. Then what I've just explained actually is reconciliation. Okay, reconciliation, which simply is the repeated process of comparing the desired state, okay, with the live state and correcting differences. As simple as that. Then the other one will be a drift. Okay, so a drift simply means the difference between Git and the live cluster, or the difference between the desired state and the live state. For example, Git can declare one API replica, but someone manually changes, okay, or manually scales the deployment to 3 replicas. So that causes a drift because Git is saying we want 1 replica, but someone manually changes the deployment to 3 replicas. That causes a drift. Then we have what we call the Argo CD application. Okay, so what is this? It is a Kubernetes custom resource that connects a Git source to a Kubernetes destination. This Argo CD application is what tells Argo CD what to read and where to deploy it. I'll repeat. Argo CD application simply refers to a Kubernetes custom resource that connects a Git source to a Kubernetes destination, for example, in our EKS. And it tells Argo CD what to read and where to deploy it. As simple as that. Then we have what we call the app project, okay, in Argo CD. So what is app project in Argo CD? An Argo CD app project simply refers to a security boundary, and it limits which repositories, it limits which clusters, it limits which namespaces, and which Kubernetes resource types a group of applications may use. As simple as that. Simply limits which namespace, cluster, repository, or Kubernetes resource type a group of applications may use. Then I'll need to touch on the sync status, okay? So you'll see me mention sync status soon. Yeah, so this is just simply like an intro to Argo CD in a summary, okay? In case you don't know it. So for sync status, we have 3 statuses, okay? There is what we call, let me put this in brackets. We have a status called synced, okay? We have synced. We have out of sync, okay? Out of sync. What else? We have, I think, also unknown, okay? If I'm not wrong. Yeah, unknown. So Unknown simply means that Argo CD cannot currently calculate the comparison, okay, of the status. Out of sync, it means Git and Kubernetes differ. It means we have a drift. Synced simply means that the live Kubernetes resources match Git, or the live state matches the desired state. Okay. Then I think we have another one called missing. Okay. Missing. So missing simply means that a required live resource does not exist. Yeah. I think I should break this up on another line. Okay, let's continue. Another term is bootstrap. Okay. If I say bootstrap, what will I mean? So to bootstrap simply means the initial installation that is required before GitOps can manage anything. Okay. So Argo CD cannot install itself before it exists. So the infrastructure workflow needs to install it with Helm first. Okay. We want that bit to be automated. That if Argo CD does not exist automatically, it is installed, okay, using Helm for the first time. Then there's what they call CRD. I'm sure many of you already know this, but CRD is a abbreviation. The C stands for custom, the R stands for resource, the D stands for definition. So custom resource definition. And a custom resource definition extends Kubernetes with a new resource type. Argo CD installs the CRDs such as application and app project. Okay, so application, okay, and the app project that you're going to see are CRDs, okay, and also Doppler is responsible for installing the Doppler secret CRD. Okay, so what we touched on in the past live stream, okay, is a Doppler secret CRD. Then we have, I think, the finalizer. So this simply is a detection guide, okay, which is attached to a particular Kubernetes resource. And this finalizer lets a controller clean up managed child resources before K8s can remove the parent object. Yeah, think of it as a, can I say a cascade delete if you're aware of databases. Yeah, simply say that if we have a parent object, okay, delete all its children before removing the parent. You'll see this soon in the config. So we have what we call a sync wave. A sync wave is an Argo CD ordering mechanism. You're going to see, we're going to be ordering using numbers. Okay, that this comes fast, this comes higher, this comes later. Okay, and a lower sync wave is processed fast. Okay, yeah, so they are simply numbers. Okay, so lower wave numbers will be processed fast, and you're going to see this soon. Then we have a deploy key, and it is an SSH key attached to one GitHub repository. Our Argo CD deploy key will be a read-only key. Yeah, so I might call it a deploy key or Argo CD deploy key. And it will clone the private repository because, yeah, it's what I'm working with. But of course, you guys have the public repository, so you can fork it and make it private for yourself or change the permissions however you like. Yeah, but the point is that this key will not be able to push changes. Maybe I can show you the changes. So you can see this is the previous test we had last time. I want to show you this key, and creating it is also equally easy. So you go to deploy keys, okay, right here, and you add a deploy key. Okay, so you can see this is what I added on August 19th, a number of days ago. So you can do the same. Okay, you can come here and click on add deploy key. Okay, and leave this unchecked. Don't check it. Okay, give it a title and leave it unchecked. Okay, so yeah, you can name it this Argo CD EKS staging. Okay, so that's a deploy key. But the question is, how do you create it? Okay, you can create it using SSH. Okay, So you can see here was running validation of a few things. So to create it, okay, you can use the SSH keygen tool. Okay, let me expand this so you can see it better. I'll say SSH dash keygen minus T. Okay, then you specify the algorithm. That's what minus T is for. The ED25519, not 29 but 19. Then minus C. Okay, specify the key. I think this should be the key name, right? Let's say like arrow dash argo 0. What am I doing? Argo CD arrow staging. Okay, like that. I think that is it. Then minus F. Okay, then you specify the location. Okay, where you want to store it. Okay, after that, for example, this could be maybe / I don't know, users. For example, if it's my machine, okay, / maybe in the .ssh folder, then I give it, sorry, this has to be a / then arrow underscore argo cd. Okay, then minus n, and we put empty string to mean we don't want a passphrase. Then you hit enter. Okay, so yeah, when you're done, you can now copy that key. Okay, copy the what is it called, quiz time. Do you copy the public key or do you copy the private key? Leave the answer in the comment section, but it's actually quite simple. Do a quick Google search. If you're not able to figure it out, let me know. I'll respond to you in the comment section. But yeah, you copy one of them and then you go back to GitHub. Okay, click add deploy key, give it that name, put it, I mean, put the name here, the title, and paste it here. Okay, yeah, so the question is, are we putting here the public key or the private key? Yeah, I just want you to think a little bit about it. Okay, and let me know what you think. If you fail to figure it out, let me know. It's quite simple. Yeah, but this directory that we have stored our public and private key in will have both. Okay, the public key will end with a .pub. The other one does not have a .pub. Yeah, in fact, GitHub gives you hints right here. So in case you don't get it, please let me know in the comment section. I'll tell you the actual key to paste right here, whether the public or private, but that's all you need. All right. So I've spoken for some time, but I think let's start discussing this. Where can I start from? I think I can start from this GitOps directory and go to, instead of staging, I come here to the bootstrap directory and talk about the Argo CD values.yaml directory. Yeah, so some things I'll keep repeating them, okay? And not to bore you, once I've touched on something, the next time I see it, I'll just go ahead and maybe just peruse over it very fast. So maybe I should stop recording and maybe continue recording because I think this is already too long. And to make the editing simple, I should maybe first stop here, then continue. And also to, yeah, give a break to my throat. So I'll do like I've always done, go through the configuration step by step. Maybe I'll minimize this to avoid it looking daunting and yeah, not to bully your eyes. Now, what is the purpose of this file? Maybe that's the first thing I should say. So this values file, just like any other values file we've been dealing with in Helm, it will configure Argo CD itself when the infrastructure workflow installs the official Argo CD Helm chart. As simple as that. The Argo CD values.yaml file simply configures Argo CD itself when the infrastructure workflow installs the official Argo CD Helm chart. So let's see what this is all about. Now we have server.service.type, okay, being cluster type. What does each of this mean? Server selects the Argo CD API and UI server component. Service configures its Kubernetes service, and type cluster IP makes the service reachable only inside the cluster. There are other types of Kubernetes services. Who remembers them? Comment and let me know in the comment section the other types of services you know. And this simply means that no public load balancer or public ingress is created. Administrators access it temporarily using kubectl pod forward, like you've been seeing. So I'll close this and go to configs. So configs simply contains the Argo CD configuration, and params becomes the Argo CD process parameters in Argo CD cmd dash params cm. Okay, so if you don't know what Argo CD dash cmd dash params cm, okay, you're going to understand it very soon. But simply, it's what line 8 is all about. Okay, and yeah, we are going to define those params. Okay, yeah, so params is simply short for parameters. Some people call them arguments. Okay, now line 7 says supper.insecure. What does this mean? It simply means that the internal Argo CD server will use HTTP. Okay, this is acceptable because the service is private and it is accessed through the authenticated Kubernetes API using port forwarding, and that is for us the admins. If you add a public ingress later, okay, of course you can use TLS, but that TLS design you have, of course, to review it and then implement it according to what you want to do. So let me minimize this, then go to the CM. Okay, so yeah, CM is simply the config map. Okay, yeah, simply the config map, but abbreviated. So we have resource.customizations.health.argo project.io application. Okay, so this, okay, simply writes behavior settings into the main Argo CD CM config map. Okay, yeah, it simply writes behavior settings into the Argo CD config map, and this long key, okay, yeah, simply identifies the custom health check for Argo CD application resources. And this pipe you're seeing here starts a multi-line YAML string containing code. I think this is what they call Lua code. Okay, yeah, if I'm not mistaken, yeah, it's Lua. I think, yeah, it is. It is Lua code. And so, yeah, we see initially here the health status, okay, being progressing, and the message saying waiting for the child application to report health. So you shall have this as a, like, think of it as a custom, can I say object, dictionary hash map? Yeah, something like that, like a Python dict. So what is obj? Okay, we're saying obj.status, okay, and then obj.status.health. Obj simply refers to the Kubernetes application object which is being evaluated. Okay, and like you see up here, the default state is progressing until a child reports its actual health. You're going to know what the child is, what a parent is very soon. Okay, what a child application is and what a parent application is. Yeah, so the first condition simply prevents errors, okay, when the status has not been populated. And the second condition requires a health result from the child. It requires a child health result, okay, as simple as this. So this one requires a child health result. What else can I explain here that may not be obvious? Yeah, so yeah, the child status and the message are copied into the health result. Yeah, by this line here, line 15. I don't know if this is visible. Sorry if it wasn't, if you're struggling to see, but I've expanded. So we copy it to the health.status, okay? by changing. So you see up here we have the health.status, and right here we're now changing it to obj.status.health.status. Okay. Yeah, so that's what I mean by saying that the child status, okay, and the message are copied into the health result. Okay. So this provides an empty message when none exists. Sorry about the background beeping sound. I can't even tell where it's coming from. Then here we have and then return health. Okay, return health simply gives the calculated result back to Argo CD. Yeah, so yeah, that is it for the child application health customization. Then the next one is the Doppler secret health customization. Yeah, same thing, same concept. Okay, so we have the key, which is targeting the Doppler secret custom resource. Okay, and it also begins as progressing because the operator may still be contacting Doppler. Okay, then we have the code here, which is checking for the status conditions. Okay, then we have the I pairs here. Okay, which simply loops through the conditions array. Okay, object.status.conditions. And what else? If you look at this, maybe you just, it may confuse you, but this underscore simply ignores the array index. I think even Python has this, probably even JavaScript. Okay. Then the relevant condition, okay, that we are looking for is the sync ready condition. So if the condition type is sync ready, then okay, we run this. We say the health.message equals to condition.message or condition.reason or an empty string. Okay, as simple as that. So the most useful Doppler message becomes the Argo CD message. Okay, what we get from here. Okay, and the true condition becomes healthy. Okay, a true condition becomes healthy. A false condition becomes degraded. You get. So this function returns immediately after finding the relevant condition. Okay. And of course, if no relevant condition exists, then the final return health leaves the state, okay, as progressing, which is this, what we have here. Yeah, so yeah, just making sure this is on the line, on the correct line rather. Yeah, so that is it. Of course, if you have any question, let me know, but yeah, I'm sure by now you guys being programmers, you can just look at this and know this is a if statement, this is a for loop, this is another if statement, a nested if statement, it's an else if, this is an end to the else if, else to the if, else to the loop, else to the other outer if statement, and then a return. Okay, now we have Dex notifications and Redis HA. So Dex, we have enabled false, notifications enabled false, and Redis HA enabled false. So what is Dex? Dex is Argo CD's optional identity broker for SSO integration. It is disabled for the fast staging version. Okay. Notifications can send Argo CD events to services like your Slack. Okay. Yeah. So we are going to defer this maybe to the monitoring phase. I even don't have a Slack account for this. Maybe I would send to email or Discord. Then Redis HA, okay, is just disabled, okay? Because I don't need it right now. I don't need it. And yeah, since we don't need it, we can avoid costs, okay, and resource usage in staging. Of course, for production, you may need it. So Argo CD still uses its normal single Redis instance. Okay, I think this is good enough for this directory. Not directory, but file. Let's now go to the, I'll close this. We go to this root, okay? GitOps staging root application.yaml. And yeah, walk through it. It's actually very short and easy, trust me. The root application will define the top level root application of Argo CD. Its purpose, like I've just actually hinted on it. Let me not repeat myself, but actually I should. it's simply the top level Argo CD application. If someone asks you what is the purpose of this file, simply say it is the top level Argo CD application. It watches the directory containing the app project and child applications. We are going to see that very soon. Actually, let me just show you right now. Okay. We have, okay, applications right here. Okay. And they are the child applications. You get. They are the child applications. The app project, the secrets, and the actual backend application, the first API application. And Argo CD has this concept called the app of apps pattern. Okay, so root application simply defines the top level Argo CD application. As simple as that. So let us look at this declaration, okay, line by line. And it's very similar to what we've already been doing. So API version selects the Argo CD API group and version. Kind simply is application and creates the Argo CD application custom resource. Next up, we have the metadata. Okay, let me minimize this. So metadata, we have the application being named error staging route. We have a namespace being called Argo CD, okay, which simply means that the application resources live in the Argo CD namespace. We have the Argo CD finalizer, okay, which I talked about earlier in the definitions of vocabulary, which enables cascading cleanup of managed resources, which means deleting this route is intentionally destructive to its child applications. The Argo CD finalizer enables cascading cleanup of managed resources. Then let's go on to the spec. In this spec, let me open it, minimize this other one. We have this line 9 saying project default. Okay, so I want you to know that every application belongs to an app project. Understand that? Okay, the root, which is what we're talking about right now, uses Argo CD's built-in default project because it must create the restricted error staging project before child projects can use it. Okay, understand that. Then we have here source. Source now gives us the repo URL. This is my private repo, so make sure you replace it with yours. So if you look at it actually, the repo URL is the SSH URL. Okay, so Argo CD will authenticate with the read-only deploy key that I showed you how to create, and you have to paste it on your GitHub. After that, we have the target revision, which simply tracks the main branch. Path selects the directory containing the child applications, which is what I showed you right here. Okay, the child applications in this applications directory. We have directory.recurse, which is true. It means that it will include manifests in the nested directories as well. We have destination. Okay, so Kubernetes, okay, dot default dot svc means that the cluster is going to be the one, okay, where Argo CD is running. Okay, so this simply means the cluster where Argo CD is running. Then we have these other things like namespace, sync policy. Okay, but just know that the destination is Argo CD because app projects and applications live there. Okay, in simple terms. And child applications choose their own workload destinations. So we have here the automated synchronization. We have sync policy dot automated, enabled, prune, self-heal. Each of them are true. So enabled turns on automatic synchronization. Prune removes managed resources that have been removed from Git. Self-heal reverses live manual changes that disagree with Git. Then we have sync options. Out of apply sync only and create namespace, both are true. So this first one avoids reapplying resources that already match in Git. And this other one here allows Argo CD to create a missing destination namespace. Okay, so you see this is very simple. Now we'll move on to the actual applications or child applications. So this is the top level, okay? We should create this default project, and then we shall have this top level being the parent of our child application. So we shall look at the first one, which will be the project.yaml. Let's look at project.yaml next. Let's talk about this project.yaml. The purpose is that this app project, like you can see on line 2, it limits where the staging applications can read from and deploy to. As simple as that. Now, let's go through each of the declarations we have here. Like you see, the kind is a project, okay, which creates an Argo CD project boundary. The project is named Aero Staging and lives in Argo CD namespace. The sync wave is -2. Like I explained in the definitions earlier, this sync wave simply means that it processes it before either child application. The project must exist before an application can reference it. So I'll close this and go down here. So right here, we simply have a normal description, which is a simple human readable UI metadata. Source repos allows only this private repository. Please change it to your own. Then just know that child applications cannot introduce resources from an unapproved repository. Then we have allowed destinations right here. So both destinations are restricted to the EKS cluster. Okay, so the Aero staging, okay, contains the API worker, like we should expect, or no. Did I say API worker? That is wrong. It's supposed to be API and worker because they are separate. Okay. It contains the API worker, the job, service, ingress, and the generated or created backend secret. Okay, for Doppler. And of course, the Doppler operator system, like we know, contains the Doppler secret. Can I call it the Doppler secret instruction? Okay. And the operator authentication secret. So production and unrelated namespaces are not approved destinations. Yeah. So think of it as just limiting. Okay. So this in short is the approved destinations that should be dealt with. Then we have the allowed namespace resources right here. We have group and kind, both of them having asterisks or stars. So this one means that it permits all Kubernetes API groups for namespace resources, and this one permits all namespace resource types in the approved namespaces. Yeah, this is broad within those namespaces, but does not grant cluster scoped resources because then cluster resource whitelist is present. Okay, rather it's not present. Okay, we don't have a cluster resource whitelist which is present. So all the CRDs, like I mentioned earlier, all the cluster roles and other cluster wide resources remain infrastructure responsibilities. Now let's go to another one, which would be this, the backend secrets.yaml. So I go to the top and you can see the things are very similar. What is the purpose of this file? It is a child application, okay, which renders the reusable backend secrets Helm chart and creates the Doppler secret resource before the backend deploys. So let's look at the identity wave and finalizer. So our application, okay, lives in Argo CD. This is the name. And the wave is -1, okay? It runs after the project at -2 and before the backend at 0. So remember, I showed you the project. Open this at -2. It runs before this project at -2 and before the backend at 0. Okay, the backend at 0. Okay, so let's go back to secrets.yaml. Then the finalizer cascades deletion to its managed Doppler secret. Then let's talk about this other section of spec. So in the spec here, we see that the application must follow the repository and namespace restrictions defined in the error staging app project. Okay, yeah, so I guess now you know what the app project is. Okay, so this project is this. You must follow the definitions or restrictions rather defined in the error staging app project. Then let's look at the first resource, which is the reusable Helm chart. First of all, sources is plural because the application combines a chart source and a values reference. The chart comes from Helm backend secrets right here on line 15. Okay, so by now I'm sure you know what the repo URL and target revision are because I touched on them a few minutes ago. So this simply tells us where the chart comes from on main. Okay, and we have looked at this in the past live streams and videos. Then, of course, like we know, the release name gives Helm rendering a stable release identity, and this dollar values, I think, is the only new thing I see here. But think of it as the values path, okay, which supplies staging specific Doppler identifiers. And this is simply pointing to the specific YAML file. Then we have the second source. So we have the first source right here, okay? Then the second source here, pointing to the same repo, same target revision, okay? But here the ref values, okay? So this values creates the symbolic values repository root, okay? Yeah, so this, when I say it creates the values repository root, I'm meaning it's creating this dollar values repository root, okay? Yeah, so what next? Yeah, but it simply lets a chart load values stored outside its chart directory. So both sources use the same repository and branch like you have seen. The destination, okay, so I think you've seen something, okay, a pattern. We have sources and destination, and then the project. You specify the project, specify the sources, and then the destination. So for the destination, the rendered Doppler secret is created in the operator namespace right here. Okay. Its manage secret.namespace settings separately tells Doppler to create the backend secrets in the error staging that we defined. And then we have reconciliation options right here. And they're similar to what we had before. Okay. So enabled, prune, self-heal are all true. Okay. And it simply means that we have automatic sync, automatic pruning, and self-healing, which make Git authoritative. Okay. Yeah. So we have the apply out of sync, true, create namespace, true, and a new one called respect ignore differences equals to true. Okay. So like I said earlier, this first one reduces unnecessary applies. Then this one here creates the namespace if needed. Then this one here honors any field specific ignore rules added later. So currently there are no ignore rules. So that last option, okay, yeah, has no real rule effect yet. Okay, yeah, it's added it for knowledge sec. You can do without it if you don't need it. So you can see that the pattern is the same. You have the sync options, you have the sync policy, destination, sources, project, okay, and spec. So yeah, pretty much the same ordering. So I'll go to backend.yaml. I mean, you can see the same structure, okay, is everywhere. So the purpose is that this child application will deploy the backend API, the worker, the migration job, service ingress, the HPA, the PBD. Is it PBD? It's actually PDB, not PBD. The pod distribution budget. Okay, and all these will be deployed from the reusable backend Helm chart. The application object lives in Argo CD. Okay, and this is its name. You can see the API version and kind of the same like we have seen before. Then the wave 0, like we see here, okay, comes after the project and secret applications. Okay, it comes after the project and secrets application. Then we have finalizers here, okay, which simply enables cascading deletion of the managed backend resources. Project is error staging, okay, which means it applies the restricted staging repository and namespace policy. Then we have similar syntax again we have been seeing. You see that we have the Argo CD, okay, same project sources. We have here the destination sync policy, okay, same stuff, okay. Maybe just to go through it one more time, okay. So this simply means that Argo CD reads the reusable Helm chart from Helm backend, okay. This is the release name. We see that the repo and target are the same for both sources, okay. Yeah. What else can I talk about here? Yeah. So maybe this, okay. The values files, okay, which of course we have touched on in the past, okay. But this one supplies the stable staging behavior, such as replicas, resources, ingress, class name, host name, and config map reference, okay. Then this other one, the second one, supplies the mutable image repository tag, okay. You're going to see it soon. And Helm applies later values over earlier values, like we have learned. And this keeps frequently changing deployment identity out of reusable chart defaults. Then we have the values reference here, okay? So yeah, this source simply defines the dollar values at the root repository. So it allows both values files to be referenced consistently. Click that. So for the destination and sync policy, yeah, pretty much the same. So all backend resources deployed to the error staging in the EKS cluster, and the automated prune, okay, and self-heal this enabled, okay, and sync options have the same meaning as in the backend secret application that we just talked about. So yeah, all this is the same meaning. It does not change. What else do I need to talk about? So I can close this, close this. So now I need to go to values, okay, right here, and talk about the backend secrets.yaml. Okay, it's very short, so don't worry. So here, the Doppler.project selects the first API backend Doppler project that we know about. Then the Doppler.config simply selects the staging configuration in Doppler, which is called STG. Then manage.secret simply tells the operator where to create the resulting backend secrets Kubernetes secret. Okay, as simple as that. Yeah. So the backend secrets, okay, Kubernetes secret will be called, will be stored in the namespace called error staging. Yeah. So yeah, we know that that file will contain identifiers. Rather not the backend secret file, but rather this file here. Okay, it contains identifiers, not secret values. Okay, so the sensitive Doppler token remains in a protected GitHub action secret, okay, and a Kubernetes secret in the Doppler operator system. Yeah, but maybe we don't need to over talk about that and complicate it. But simply, this one simply selects the Doppler project in Doppler, the configuration for staging, and the namespace where the operator will create the backend secret for us. So close this and move on to the next file, which is this one here. Okay. Now, this one here, first of all, what you're seeing at the top, okay, let me minimize this. Line 1 and 2 is simply an image. Okay. An image. What am I even saying? I think my mind is getting tired. Line 1 and 2 are comments. Yeah. So we're just describing the promotion contract. Yeah. And you can see it's a very simple and empty file. Yeah. So the CI, or the continuous integration. Okay. I almost beat my tongue saying continuous integration after saying CI, but the CI must push the image tag before recording its tag in Git. Okay. So it is pushed to ECR, then it is recorded in Git. Okay. And here we have the desired state. So image.repository is the backend ECR repository. Okay. Then image.tag is the exact image staging should run. Okay. Then bootstrap, this is what you're seeing here, the bootstrap required. Okay. This is simply an initial placeholder. Okay. Which will be replaced by the fast deployment workflow with the correct source commit SHA. Then the policy here, or the pull policy is saying if not present, avoid this downloading an image again when that immutable tag already exists on a Kubernetes node. So after the promotion, the relationship will be like so. Let me try to put it here. It will be, we have the source commit SHA, okay, then the ECR image tag, okay, which will now give us the GitOps desired image tag. So I hope this makes sense to you. Okay, so I'll remove this. Let me see. Then of course we just have a README, which is simply the operator documentation. So Kubernetes and Argo CD do not execute it. Okay, yeah. So I used AI to generate it. Okay, yeah. So you can also read through it. It won't be executed. So I think I'm done with this GitOps directory. We need to move on to the scripts in the .github. Okay, need to just get in here. I realize that you have other changes down this side, but they're not so many. So let's talk about, yeah, the scripts here, and we get done with this. So for the scripts, if you look at my terminal, let me expand it. Okay, I actually executed one of them. Okay, where is it? Right here. Okay, and it did well. Okay, it passed. So maybe let me go through them at a time. I'll start with the validate GitOps. Okay, dot sh right here. And yeah, so don't be confused. I'll just explain a few things. It's not actually very, very difficult. It's easy when you think about it. So here we have a shebang, okay? At line 1, let me expand this, zoom in rather. So it selects the bash, okay, through the current environment. Okay, that's what line 1 is all about. Then we have this other line. I think I've explained something like this many times. So -a simply stops on unhandled command failure. Then the U stops when an undefined variable is used. Then pipefall makes a pipeline to fail when any command in it fails. Okay, so the CI invokes the script with bash so that executable permission is optional. Then we have this, okay, repository root, okay, and says git reverse parse short top level, okay. It simply finds the repository root. Okay. Yeah. So we just want to find the repository root, as simple as that. Okay. Then, like, command substitution. Okay. We'll store that path. Okay. We'll store the path that we want. And then here, simply, okay, makes all subsequent relative paths. They say paths. Guys, I'm tired. CD makes all the subsequent relative path, okay, reliable, regardless of where the script was launched. Yeah, that's why I did the CD root repository. Then we have an array, which is called required files. Okay, so this bash array list, okay, stores all the workflows, all the Argo CD manifests, all the value files needed by the GitOps contract. Guys who are good at DevOps, please, this is my first time doing GitOps. Please tell me if there's a better way you can handle this. Okay. Yeah. So the idea is that a missing file should fail validation rather than silently disable part of the deployment. Yeah. So let me know. So you can look at the code. Then I have a file existence loop. Okay. Yeah. So the loop simply visits every array item. Okay. So we look at this first line. Okay. It's looping through the required files. Okay. And I don't know what I can explain here. So just know that the quoting preserves the exact path. Okay. That's why you're seeing the quoting that we have here. Okay. And minus F simply means that we are requiring a regular file. Okay. This bang, okay, or exclamation mark simply negates the test. Okay. So this is a regular if statement and a regular for loop. Maybe do while loop rather. Okay. But yeah, for loop will be better. Yes, a loop in general. Then what else is not obvious here? This one here. Okay. At the end. This ampersand then 2 simply sends the error to standard error. Then exit 1 makes us to know that the validation is failed. Actually, not us to know about the CI. It's simply marking the validation has failed. Because in Linux, when you exit with 1, it means a failure. If you exit with 0, it means things worked out well. Then we have YAML syntax validation. Okay, so actually I used AI to generate this. Okay, I'm not a Ruby expert, but this is Ruby. I'll explain to you what it is. I'm sure many of you have been programming for a long time. You actually understand some of these things. So Ruby here simply starts the Ruby interpreter. Okay, then this RYAML, okay, loads Ruby's YAML library. Okay, and minus E executes the quoted Ruby program. Simple as that. So file path after the code become the argv array. Okay, so argv is simply the argument you pick from the command line. Okay, yeah. So so you're saying from argv.each do this. Okay, so for the first one, if you look at line 31, okay, we do a file.read. So we are reading each file. You get, we read each file, and the YAML.load stream passes one or more YAML documents. Okay, it's simply a function to parse. Okay, so empty documents and syntax errors are bought with useful messages. How do you know that? By line 32. Okay, yeah. What else can I talk about? So we have here required text contracts. Okay, RG. So we have RG required fixed strings, then the fixed strings rather, then the YAML or the file. Okay, so RG is a, and I call it a rip grep. Okay, if you know what grep is. So quiet prints nothing and uses only its exit status. So fixed strings treats the pattern literally instead of a what am I even saying? Fixed strings treats the pattern literally instead of as a regular expression. Wow, I've been talking for long. I'm trying to record everything about this GitOps session in one day. Well, let me say in one moment, okay? I've been recording for the past maybe 1 hour or so. I'm starting to feel the tiredness. But let me continue because I want to finish it. If I don't finish it now, I may not get time to do it. Then Yeah, so I was saying quiet prints nothing and uses only its exit status. Then fixed strings treats the pattern literally instead of as a regular expression. So these checks require the private repository URL, pruning, self-healing, and the expected sync waves. Yeah, so you can see these are the regular files we've been talking about. So I said the checks require the private repository, pruning, self-healing, and the expected sync wave. So you can see that prune true, self-heal true, the sync wave here, the sync wave there. Okay. Okay. Then now we got the things that we know. Okay. The Helm validation. Okay. The backend Helm validation. So you have the Helm lint, which checks the chart structure and values. I feel like skipping this, but I won't, okay, just to make sure that you guys understand this and reinforce it in your mind. Okay, strict looks new, but it simply turns lint warnings into failures where supported. Okay, so both stable staging values and mutable GitOps values are loaded. Then we have the Helm template, which performs a complete local render without touching Kubernetes. Okay, and error backend is the release name used during rendering, like we have been seeing. And of course, namespace supplies the intended namespace to templates, and output is discarded because successful rendering is the test. As simple as that. So what do I mean by output is discarded? By this line of code. Okay, not line of code, but this code I've selected. Okay, dev/null. Very common in Linux. Okay, by now you guys should know this. Okay, so the backend secret chart is linted and rendered the same way with its own values and destination namespace. So we're done with Helm. Okay, we have the RG quiet fixed strings. Okay, so we just here, I think, trying to prevent direct Helm ownership. Okay, so think of it as an inverted check. Actually, it is an inverted check. Okay, finding the old direct deployment command is a failure. So it prevents the CI and Argo CD from both owning the backend. Yeah. So that's why you're seeing this Helm upgrade install. Then we do this GitHub Workflow file also being checked. Then, okay, you simply have that message and with an exit of one. Yeah. So like I said, it's an inverted check. And finding the old direct deployment command is a failure. So it prevents the CI and Argo CD from both owning the backend. So let's look at the workflow contract checks. Okay. So we have additional RG commands. Okay. And they require contents, and write is for Git promotion. We have the GitHub. What am I even saying? I'm saying GitHub, not GitHub, but the GitOps backend values path in the deployment workflow. Then we have the Argo CD chart version 10.2.1 in the infrastructure workflow. Then we have the, at the end, the root application bootstrap in the infrastructure workflow. Yeah, so let's see. Then we have the safe order, not safe order, but the safe destroy order test. Which says workflow equals to yaml.load, blah blah blah. Okay. After I researched on this, I discovered actually these guys use a lot of Ruby. Okay, but it's actually simple if you think about it. And let me explain. So Ruby passes the infrastructure workflow as structured YAML. Okay, and we may, by the way, you may be thinking why Ruby? It's because Ruby has an inbuilt YAML parser. Okay, so you don't need to install a third-party package for just parsing YAML. It's inbuilt into Ruby itself. Okay, so I was explaining this last part. Okay, the Ruby, okay, like I said, passes the infrastructure workflow as structured YAML. Okay, YAML.load file. Okay, and it locates the exact destroy step by step. So the fetch fails clearly when an expected object is missing. Okay, as simple as that. So you can see we have a workflow.fetch jobs, okay? .fetch Terraform.fetch steps, okay? We get the steps, then we look for the destroy step, okay? Steps.find, okay? We find name like this, okay? Then we abort, saying destroy staging infrastructure step is missing, okay? We need it. Then we have a script, okay? Says destroy fetch run, okay? We pick the root delete, which is simply referring to this, okay? You get. Yeah, then we have an ingress delete, which is simply referring to this, okay? Script.index delete this, okay? Then the same thing for Terraform destroy. Yeah. So each index returns the position of an operation in the shell script. Yeah, as simple as that. So if you look at this line here, okay, it requires just know that it requires deletion first. Okay. Yeah. What I'm even saying, not deletion first, it requires root deletion first. Okay. So root deletion first, then ingress deletion comes second, then Terraform destruction last. Okay, just like I've been showing you the order. Okay, so again, root deletion comes first, then ingress deletion comes next, then Terraform destruction last. Okay, yeah, so validation fails if someone later introduces the unsafe order. Then we just have up here, not up but down. Yeah, the success output. That's when, yeah, it appears, okay, what we see in the terminal only after every preceding check succeeds. And I think I showed you earlier. I run it. Where is it? Here. You're seeing this command, and the message is here. It says GitHub, not GitHub, GitOps contract validation passed. Wow, this has been long, but I'm here till the end. What else can I talk about? Let's go to the workflows, validate ops.yaml. We're almost done. Don't worry. So we have the workflow name here, okay, that we know. Then we have the pull request trigger. Okay. Since we know all this, yeah, I don't want to waste time on it. But simply it runs for pull request targeting main. The path, this one here, filters, limits. Okay. Yeah. So how can I say it? Let me lock in, like they say. I'm trying to rush and I'm failing to get the right words. So path filters, okay? These are simply path filters which limit runs to GitOps, okay? The backend chat, valid data, and the related workflow changes, okay? So you see double asterisks like this, it simply recursively matches nested path. So this is the pull request trigger declaration. This is the push, okay? And manual triggers. Why manual? When we have the workflow dispatch that I've explained over and over again. Then we have the minimal permissions here. Okay, so validation only needs repository read access. It cannot push commits or modify infrastructure. Then we have the job. Okay, so in jobs right here, okay, we have the validate, okay, which is the internal job identifier. Okay, so the long name appears in GitHub, okay, and GitHub provides a fresh Ubuntu runner. Then we have checkout and Helm setup, okay, so which is just that, which simply means checkout downloads repository contacts, and setup Helm installs the Helm CLI used later for, I think, for validation, of course. These two, okay. Then what else? So we have the pinned Argo CD render, okay. So here, okay, we simply have the official Argo Helm repository, okay, being registered and refreshed, okay. So Helm template, like we know, verifies our bootstrap values against exactly the 10.2.1 chat version, okay. So no cluster resources are created during validation. What else here? So here okay, the contract script, like you know it already, okay? I just talked about it a few minutes ago. So this simply runs the repository level contract validation, which we described, you get. And like I showed you, I did it here in the terminal. You can actually try it out for yourself. Think about it this way. This workflow simply runs the script in the end. Yeah, that's the simplest way I can summarize that. Then we can talk about this one here, the Kubernetes, the Terraform Kubernetes staging.yaml. And maybe zoom out a little bit and show you what is new. So what is new? I can start from the top. So at the top, we have new pull request path. Okay. So infrastructure validation now runs when bootstrap, root, and child application or secrets desired state files change. And the frequently updated backend image file is intentionally not an infrastructure trigger. Okay. I hope you expect that. Okay. But yeah, these are the paths that I added. Okay. Let me know if they make sense to you. If they don't, please remove. Yeah, the number of things I removed. But yeah, you can look at the git diff to see what I changed. So let me see. Let me see what else did I add. Yeah, right here. Do you see this in the destroy infrastructure? Okay, we added some can I say, what do I say, comments. Okay, yeah, but these are just safe destroy additions. Okay, so the CRD check that you're seeing here, okay, makes this compatible with clusters where Argo CD was never installed. Okay, so the output is discarded because only success or failure matters. Okay, so yeah, we send it to dev now. Simple as that. Yeah, so yeah, this is same stuff that we do. Okay, the delete application, kubectl namespace, ignore not found, wait true. Yeah, so root deletion in simple terms stops reconciliation and triggers the finalizer based cascading cleanup. Yeah, when we destroy. Remember, this is under destroy. Okay, once you delete the root, not the loop, but the root, it stops reconciliation and triggers finalizer based cascading cleanup. Ignore not found makes repeated destroy attempts safe. Okay, and wait true waits for deletion, and this is our timeout, okay, which prevents an endless workflow. So the existing ingress deletion remains as a fallback for a legacy or partially adopted ingress. And you may be thinking, where's the Terraform destroy? It's actually at the bottom. It runs last. Let me see what other change do we have here. I feel like this is too long. Okay, there should be a way of making this shorter. So we have the install Argo CD. Okay, and it speaks for itself. So this installation runs for the staging pipeline. Okay, but for the push only or an explicit apply. Push or apply. Then we have wait, actually, I hope you know that it does not run during HTTPS activation or destroy, okay, because of this if statement. And of course, we first add the official chat repository, okay, or it is refreshed idempotently. Other things we know them like upgrade, okay, upgrade installs when upgrade installs when absent and upgrades when present. Okay, this command, like we have always known, installs when absent and upgrades when present. Our chat is pinned to this version. Argo CD runs in this namespace, and it is created if missing. In our bootstrap values configure the installation and Helm waits for readiness up to 10 minutes. Then we have, I think, the repository authentication step, which is named configure Argo CD repository authentication, which uses the Argo CD repo SSH key that I told you to generate at the beginning. And like we know, pipefall protects the secret creation pipeline. Okay. Yeah. So yeah, what we have here, let me see. Yeah, so here we simply, I think this simply creates what I call a no op command, okay, which is used to evaluate parameter expansion. Okay. And what am I looking for? This, okay. It simply stops, okay, with the supplied message when the secret is missing or empty. What else do I see? Of course, this pipe, means that we are running a multi-line instruction or command. All right, what else? So we have here printf, which is helping us to send the private key through the standard input without printing it. Yeah, so we printf that key through standard input to the kubectl command, which also sends its result as standard input to the kubectl apply. Yeah, so like create secret, generic constructs the Kubernetes secret, okay? And literal fields identify Git repository and its URL. Okay, and of course we know that client dry run, okay, emits YAML instead of immediately creating the secret. Then of course kubectl apply -f contently creates or updates the YAML from standard input. Then what do we have here? We have this label, okay, which is being, of course, like we know, attached to a particular namespace. Even up here, we've specified the namespace. I'm skipping some things because we have done them again and again and again, and I don't want to waste time, okay? So the label simply tells Argo CD that this secret is a repository credential, okay? And this override, think of it as a way to support credential rotation. What else? What else? I think we have there the GitOps bootstrap replacement. So the old direct Helm installation of backend secrets is what was removed, okay? And it was replaced with this, okay? kubectl apply -f, this GitOps YAML. Okay, so the infrastructure workflow creates only the root application. Okay, that's why you see it's pointing to only root. Okay, yeah, it is not pointing to these others. Where are they? These, okay? Only to the root. Yeah, so what we do to the root, okay? The Argo CD creates the project, okay? And the child applications. Yeah, so yeah, this is common syntax. Okay. We are simply waiting for the root application sync status to be synced, okay, by this. When you see wait for, okay, this, we're waiting for the status of this root application which we are creating to be synced, okay, and we have a timeout of 5. Then we have here another one, okay, yeah, but I think you guys know this stuff. So because like when you see this, okay, let me not skip it, let me explain it. Just know that the JSON path reads the exact status field, okay, by saying status.sync.status. Okay? Its value should be synced. It's a string. Yeah, so this one simply confirms that the root created the secrets child application, and of course the existing Doppler waits. Okay, yeah, waits. Then we wait for that sync ready. Okay, remember the sync ready status. Yeah, so we have to wait for the sync ready and the generated backend secrets. Let me see. Yeah, that's the end. There's no other. So I think by now, guys, you should see a pattern. Okay, we say kubectl, we specify the namespace, provide the namespace in a variable. Okay, and you can wait. Okay, based on a particular condition. Okay, yeah. And of course, you can put timeouts. I'm not seeing anything else. What else? What else? What else? Oh, actually, there's one here. Backend. Even this other one, I don't think I've talked about it. Staging.yaml. Staging.yaml actually has very few changes. I don't see anything big here. Okay. I just changed, I think, the permissions. If you look at here, okay. I added contents, right? So contents changed actually from read. Yeah, it changed from read to write. So that the call deployment workflow can commit the promoted image tag. Yeah, remember, the workflow needs to commit the tag. Then ID token is right. Okay, it remains for the AWS OIDC role assumption. So reusable workflows cannot elevate beyond the caller's permissions. The parent must grant the content right access. Then we can now look at this other one. Also doesn't have, I don't think it has much. Oh, actually look at addition. I think there's a number of stuff. But maybe I'll start from the top. Okay. So in the same way, content right access is required to push the desired state commit. Okay. Then the OIDC permission remains for AWS. Okay, it remains required. Then Argo CD namespace is just added here. Okay, so these are just, think of it as reconciliation checks. Okay, I need to read the application objects from this namespace. I think I'll minimize that. What else? Okay, we have here the checkout. Okay, with fetch depth 0. Okay, simply mean that the full history is needed for branch switching. Okay, not only branch switching, but this is switching or switching. Sorry, full history, like I said, is needed for branch switching, committing, revision tracking, and pushing. One of the things I don't like about recording video is that you have to speak for long and sometimes you have to edit. Okay, you have to edit when you make mistakes, like in your voice. But if it's a live stream, everybody sees that you're making a mistake and we carry on. Okay, but anyway, let's continue. What other change do I have here? Okay, so here we see that now in this command, okay, we now have both Helm lint and Helm template, which now include the mutable GitOps image file. Okay, let me see. I think this, yeah. So validation data for render is the same layered values which Argo CD will use, and the command line image settings will still validate the image built by this run. Yeah, so it's simply validation. So if you look at this line, we have the same GitOps staging backend.yaml. Okay. So if I remind you, GitOps staging, not applications, but values backend.yaml. So these two, the important file which will be updated, okay, with the current tag. Okay, I need to go back up here. What else? Promote the backend image in Git. So this one, let's simply is a replacement. Okay, we removed the, what's it called, the direct deployment. Okay, yeah, so the entire deploy backend thing, okay, with Helm was removed. Yeah, so we now have the CI and Argo CD have to own the same resources. And yeah, we have an ID called promotion. Okay, simply allows later steps, okay, in this workflow to read its revision output. And here, simply the ECR repository, okay, which will be needed. So we just simply resolve it earlier, okay, and it will become an environment variable. So run again, pipe means running a multi-line command. We git fetch, like we know, fetch will simply update the remote main reference, switch force create, okay, it either creates or resets a temporary local branch, okay, temporary local branch promotion from the latest remote main. So it simply avoids promoting an outdated local branch state. So yeah, we're simply, think of it as refreshing main. Then we have updating the image. So we're using a tool called sed, okay, to update this file. I think this file here, yeah, where we're storing the GitHub tag, okay, and the tag is simply the current commit GitHub SHA. So using sed, okay, we edit the file in place. So like I said, values simply avoids repeating the path, we're simply storing it, okay. So sed -i edits the file in place, okay. So this first expression simply replaces the indented repository line, okay, as simple as that. Then this one replaces the indented tag with the source commit SHA, okay. So you're replacing the repository line with this, replacing the tag with this, as simple as that, okay. Then yeah, those pipes you're seeing, it's simple, they're used as a separator because the repository file values contain that forward slash. Yeah, so just to remind you. we are trying to update this, okay? Repository, then tag. Let's get back here. Then we have the no op protection. We all know what a git add is, okay? So only the state file is changed, okay? That's the whole point of this, okay? So git diff cached quiet, okay? Detects so that the stage content changed. As simple as that. So an unchanged deployment creates no empty commit. And the current revision is still published as a step output. Wow, this has been long. So we have the actual promotion commit, okay? So we do the git config username, okay? So yeah, the whole goal is like you see, okay, let me explain this step by step. We put the username like usual, okay, when you're setting up Git, especially for the first time, the username, the email, the commit message, then we push, okay? Yeah, so like you're seeing, this commit has a clear automation identity. That's what we're trying to do, okay? And the GitHub SHA:12, okay, shortens the source SHA in the message, okay, in our commit message, as simple as that. Then skip CI requests that normal pull request workflows. Actually, not only pull request workflows, but even push. So it requests that normal push or pull request workflows skip the automation commit and helps us to avoid deployment loops. Then the temporary branch is pushed to the remote main, okay? And then, yeah, the new desired state commit SHA becomes the revision output. Yeah, what we are seeing right here using echo. Then we have the reconciliation wait, okay? We have a new environment variable, okay, called desired revision. So the wait target, wow, what am I saying? The wait targets the exact git commit created or used by promotion. So we have a for loop, okay? So this simply says that the loop, okay, our loop is going to help us to allow for about 120 checks. So that's why you see the 1 to 120, okay? And each failed check sleeps 5 seconds. How do I know that? Okay, look at this down here, okay? It sleeps for 5 seconds. Guys, I just said seconds instead of seconds. I'm really done, okay? So it sleeps for 5 seconds for a maximum of about 10 minutes, okay? And we have done this a lot. So each failed check sleeps 5 seconds, a maximum of about 10 seconds. I want to see if there's anything strange here that you guys may not know. Okay, let me do it, okay? The point is that this loop, okay, reads the status.sync.status, status.sync.status, okay, status.health.status. We have the status.sync.revisions, okay? So the sync must equal synced. You get, I think here should be equal synced. The health must equal healthy. You get. So the reported revisions must contain the promoted git commit, okay? And errors are temporarily tolerated, okay, and are sent to the dev null. So you see, we have the del null or true, okay, because the application may not yet be available during the early attempts, okay. So yeah, why sleep? Because we want to prevent aggressive, yeah, polling. So we want the final attempt to produce a clear error, okay, in case we have reached the attempt 120. So yeah, I think there's nothing really strange here. So you see the sync status, we are picking it from kubectl, okay? So you're saying get this application called this, and the output, okay, should be picked from this, okay? Then we pick the health status, the revisions, okay? Yeah, same structure. You see kubectl, specify the namespace, get the particular application that you want, and specify your output. And if anything fails, we send it to dev now. Okay, then our usual failure diagnostics. So in the CI, we now record all application summaries, okay, and detail backend application events on failure. And this pipe true simply ensures that our diagnostics do not hide the original failure. So the existing Kubernetes pod, the job, the ingress, the log, and the event diagnostics remain. Yeah, I think that's it for here. There's no other change. Again, if there's anything confusing you, please don't hesitate to leave a comment. Yeah, I know this has been a long one. It's going to test your longevity or constitution span. So let's finally look at this one here, the GitHub actions. Maybe I should have begun from here, okay? But it's not complex, it's actually very simple. In fact, I should end with it because it's simple and we have done Terraform like 1,000 times. So one Terraform resource has been added, okay? And this resource simply associates an EKS access policy with an IAM principal. And GitHub actions, okay? Argo CD view, this one here, okay, is simply Terraform's internal resource name, okay? So we have the usual stuff, the cluster name, principal RN, the policy RN, okay? Access scope and depends on that we have seen over and over again, okay? Same concept, but simply a different resource, but the concept remains the same. So the association applies only to the staging EKS cluster. How do you know that? By this, okay? And the principal is the GitHub deployment IAM role. How do I know? By this value, AWS IAM role.githubactions.arn, okay? The AWS resource name. Then the policy RN, okay? Yeah, so the Amazon EKS view policy grants read-only Kubernetes visibility. Okay, so the RN is pointing to this, okay? We're being explicit this time. Okay, so this policy is called the EKS view policy, and this whole thing is the RN. Then we have there the access scope. This policy number one, you should know that. Wait, what's this? Sorry, I got a distraction. The policy is namespace scoped rather than cluster wide. And the deployment workflow may read Argo CD application status in Argo CD, okay, in this namespace. Yeah, so it is namespace scoped. That is what this access scope is all about. Simply says we are namescaped. What's happening? I say namescaped. This access scope simply means that the policy is namespace scoped and it's not cluster wide. And our deployment workflow may read application status in the Argo CD namespace. Okay, so you're saying it is a namespace. Okay, it is scoped to namespace. And which namespace? It is the Argo CD namespace. Then you have the depends on, which means that Terraform must create the EKS access entry before associating the view policy. Wow. So yeah, let me run this, then we continue. This has been a long one. I guess I need to first stop recording, take a break, and then yeah, push and show you the changes. So guys, like you see, the install Argo CD step is running, but these things really take long, so I don't want to keep you guys here for long. I'll be back when it's done. So let plan and apply staging infrastructure get done, then we go to the deploy, test, and build. Yeah, stage. So yeah, let me pause this and then get back when things are all good. So here's an update. Install Argo CD complete. We're now down here. Okay, watching. So guys, look at this. I've got some success, but I've also learned the hard way. I got stubborn and allowed AI to do what it wants. I told it to add possible concepts I might have missed, which could be important. And it resulted into pain. So if I go to actions, you'll see that the number of things actually, yeah, failing. But yeah, lesson learned, and I'm now back to normal. Yeah, I've been humbled by it. So now things are okay. You can see the API here. Okay. The docs are okay. So probably, of course, I'm going to take it down, and I've lost track of so many things I changed. Actually, there are not many, but you can check the Git diff, but importantly, have a list here, okay, of what changed, like the role-based access control. I've removed the ineffective EKS view policy. These are an additional recoveries, okay? Yeah, so you can check and see what I've changed. In case there's anything that is extra that you don't understand, please let me know in the comment section. But it's actually pretty basic and easy to understand. Nothing is new concept-wise. Yeah, so here you'll see more error that gives you more information about what went wrong and the report status. Anyway, yeah, so that's it. So in the next video, I think we can wrap it up by setting up monitoring for this project. Have a good one.